Alright, so let's just look at the storm as it has progressed since yesterday at OOZ. We can see we had our parent surface low over New Mexico, occlusion, and another low pressure forming off of that. We can see slowly that low pressure became more disattached, and then what happened is that we started getting cyclogenesis off towards the Texas coast, and then this low pressure started to mature, and it has since matured into a decent low pressure over Louisiana, where there's currently some rain, as we can see over here in the surface observations. And this will generally track this way. It's going to track inland, over land, and then off the coast, like that. Uh, Look at the satellite loop. Currently, we can see clearly there is a lot of cloud development with that low pressure. Looks like there's a line of storm associated with it. Definitely a healthy storm. We can see it's probably some kind of upper level low over here, probably from the parent low moving this way. We can verify that with the 300 millibar jet stream map. Here's our upper low, and our low pressure is over here around. And this is going to move up the jet stream like this. It's going to follow the jet stream. The jet stream itself is also going to be moving, so it's not like it's going to go this way and then that way. It will go around like this, something like that. So let's look at currently the warnings and watches that are in effect. So we can see winter storm warnings as far south as North Carolina, the North Carolina-South Carolina border over there. Mainly in this region, the advisories and warnings are for freezing rain. And north of Maryland, I would say, everything's mainly for snow. So we can see the warnings extend a large portion of upstate New York, not really like far upstate, but just upstate. Northern New Jersey, a lot of Massachusetts, northern Connecticut, a lot of Pennsylvania, and the high terrain in places south of that. And we look at the WPC's short rain forecast just to see an overview of what's going to happen. We can see currently the rain is over Louisiana, the southeast, and the storm is just going to track northwards. We can see our freezing rain across Virginia and North Carolina. And then the storm will move into the northeast, bringing the snow, and then it will move away by Sunday evening. Alright, so let's see what's changed since the last update that I gave you guys. The main thing that has changed is the storm has trended northward and it has trended slightly fastward. So let's look at the GFS trends right now. Watch this low pressure over here. This is the storm. This is at Saturday, 7 p.m. So these are the oldest runs. These are the newest runs. Let's look at the trend. So clearly we can see in the recent runs there has been a significant shift northward and inland. That's another trend that's been there. So we compared the latest run down towards the Carolinas to the latest run, pretty much straight north from there, not even offshore, straight north, significant area over Maryland, and it is inland. Oh, this is with the European, that's my bad. And then we look at the GFS, it's going to verify with that trend as well. Significant northward shift over the last few runs, although this one is further offshore. Verify with the Canadian, it is a little more weird. It's not really as good of a model as the American and the European, but it too has shifted northwards slightly. So let's look at the synoptic scale of this storm. So this is the 21Z RAP model, a very good model for analysis in the short term. We can see our upper level low is situated. This is the 500 millibar vorticity. Vorticity is generally like just spin in the atmosphere. And these lines are the height, really can just show you areas where there are low and high pressures, ridges and troughs, things like that. So we can see a big trough set up over the central US right now. Low pressure sitting over the Midwest, and that is the upper level low pressure. And then that is touching off cyclogenesis over the southeast Louisiana area. And that is going to move northwards up towards here. This is Saturday morning into the mid-Atlantic. And then it'll really start to strengthen towards Saturday evening. You can see these brighter colors. And then as it moves offshore, it's going to start to develop into its own storm. And we can see by the end of the period, Sunday evening, as it's moving offshore, we have a much deeper low over here. Our old surface low is developed into a new upper level low. So let's move on to look at the temperature advection at 700 millibars. which is a little bit lower in the atmosphere. 500 millibars is around 6 kilometers up in the atmosphere. 700 millibars, I don't remember off the top of my head, that's around 3 kilometers above ground. So if we look at the storm as it moves in, this is the HRRR model, we can see these green areas are area where frontogenesis is occurring, where a front is forming, a weather front. And the red areas are where temperatures are increasing, and the blue areas are where temperatures are decreasing in the upper levels of the atmosphere. So basically we can see fronts are starting to form, a lot of temperature advection off the Atlantic as this low pressure comes in. This is at Saturday, 7 p.m. And we can see as this moves into the southern northeast area, Massachusetts, Connecticut, Long Island, that area, at around 10 p.m. Saturday, we can see it really starts to get its act together. And by 1 a.m., it's really starting to get strong. And then by the next day, it's pretty much developed into its own upper level and lower level system. We'll come back to the frontogenesis. It'll be important later when we're talking about the actual snowfall out of this. Same thing with the 850 millibar temperatures we're talking about here. 850 millibars is the 1 kilometer above the surface, so it's pretty important to what happens at the surface. So let's look at the temperatures, and we'll also be looking at the wind barbs. So we can see this is the HRRR model, I believe. Yes, it is. And we can see as the low pressure is situated around here at this time, Saturday at about 3 p.m. We can see with this low pressure, it's bringing warmer 850 millibar temperatures that are above 0 degrees Celsius. So we can see as that moves in to, especially in New Jersey, Pennsylvania area, we can see the 850 millibar temperatures rise above 0 degrees Celsius. The low pressure centered around here over southern New Jersey. And the reason being is that you see all these wind barbs over here. The low pressure is bringing in warm and moist air from the Atlantic Ocean, which is actually pretty warm at this time. It's not as cold as you would think it is. And that warm and moist air is making the air over land because the wind is blowing towards land. It's making it warmer, and that leads to the temperatures rising as the low pressure pulls the air this way. And of course, on the backside, then when the winds are coming off of land this way out of the west, then the temperatures are going to decrease again. But basically, anywhere around the center of the low, and especially on the east side of the low, the temperatures will be higher. So we can see basically as the low is developing over southeast Pennsylvania and New Jersey, a lot of the area, 850 millibar temperatures rise above 0 degrees Celsius. And the coastal northeast, the temperatures are above 0 degrees Celsius as the storm is developing. So these temperatures will be very important to the snowfall when we look at it later. Same thing with that frontogenesis. And finally, we just look at the surface pattern. The surface low will be a bit detached from the 850 millibar low. It will be about a difference of maybe say 50 miles. 850 millibar low would be over here, more over land. Again, that's also going to make a difference in basically who gets snow, who gets rain. Wind-wise, the system won't be too crazy. Obviously, it'll be gusty as with any nor'easter. But as it starts to get its act together and moves away, definitely Cape Cod could see some strong winds. All right, so let's move on to the simulated reflectivity from the models. So this is the HRRR model, one of the most trusted models, one of the best. I believe it is pretty much the best model that the US government puts out, but it's for short range. So we look at it over here, we can see by about Saturday at 15Z would be around, that would be around 10 in the morning, and towards 1 in the afternoon, snow and rain is moving in. Already that ice and snow has been ongoing since the early morning hours across Virginia. And we can see the precip, basically all of New Jersey is having rain or snow by the 4 p.m. time, Eastern time. And we can see a lot of snow expanding over Pennsylvania as well and into upstate New York. We can see as the low pressure comes through on that and basically ends the rain and the snow, at least the heavy ones, in New Jersey and Pennsylvania. And then the storm starts to move into the classic northeast, southern northeast area, Massachusetts, Connecticut, Rhode Island, that area. And that's where some of the highest snowfall totals will be, in this Massachusetts area, because that'll be as low starts to strengthen. If you see Back over here, it was a 998 millibar, 997, 995, and then 991, 987. That's when it really starts to get its act together. But by the time it's getting its act together, the strongest snowfall will be gone. And that's one of the downfalls of this system. It was looking like it was going to be a lot stronger previously, but now it looks like it's going to strengthen as it's moving away. So the heavier snow, it won't be possible. But the snow will still be plowable. It'll be some sizable amounts. Look at the NAM 3 kilometer CONUS. It's painting a similar picture, except for its low pressure is a bit deeper earlier, and it moves further offshore, which allows it to be colder across the northeast, which allows for more snow in more areas, which is what we'd like to see. But the NAM 3 kilometer model is notorious for putting out some weird forecasts, especially at this time frame of 1 day out. And really, it shouldn't be trusted very much unless it's matching up with other models. And as of now, it seems to be a cold outlier. We look at the FV3 model. This is a relatively new model. It has a special type of vertical coordinate system. And I like the depiction of reflectivity that this model is showing because it gives a pretty uh, mid-range view based off all of the different models that are out there of what could happen tomorrow, especially in terms of the rain snow line. We can see that basically southern half of New Jersey is raining and only the northern part it's snowing. Same thing pretty much for Pennsylvania. The southeast Pennsylvania area, it will be raining. And we can see as this moves into the Massachusetts area, it's going to be some pretty heavy snow out there. The only weird thing about the FV3 is that the low pressure is actually really weak until it really moves offshore towards Cape Cod. And this is outputting another like strong bout of snow on Sunday over there because of that strengthening. So we'll have to watch for that. And just to compare like all the different models we can at let's say this time is Saturday 10 p.m. So basically there are some key differences between the models that we'll talk about later when we look at the rain snow lines. But one of the key things that all of these are touching on is the potential for a snow band to move through. So if you look at the FV3 over here, actually let's just take this back to 7 p.m. just to make it more like exemplified. Look at this like area of heavy snow and rain over here over New Jersey in the FV3. The NSSL isn't as strong with it, but it has another band over here. NAM 3 kilometer has that band very prevalent over here. HRRR, same thing, very prevalent band. This is probably the best example of the band that I'm talking about. Same thing even with the global models banding over there. The RAP model, same thing. Look at that band over there. So let's talk about this band that I'm talking about. So basically, when we have snowstorms, obviously it's not really uniform snow everywhere. Some areas get more snow than others, and that's because of some bands that set up. So bands are kind of areas where there's more lift for snow and the snow becomes heavier. And generally, snow bands, they move throughout storms, but sometimes they can be stationary and that puts down a lot of snow. But in this case, a snow band will be pretty fast moving, but it will be some pretty heavy snowfall rates. So we look at the temperature advection at 700 millibars. I told you we'd get back to this because it's pretty important. Basically, these green lines, that's frontogenesis. So frontogenesis, as I said previously, that's where the fronts are forming. And this can be really important for showing you where that heavy snowfall is occurring because it often occurs near these frontogenesis areas. Along with that, the temperature advection, where warm air is being advected, that means that those areas will have moisture being driven into them, which means potential for more snowfall. So we can see comparing the different models. Looking at the NAM 3 kilometer, as I said, this is pretty much of an outlier model. Always spits out these weird forecasts at these lead times. But basically, it's showing very clearly the band over here, but it's definitely not going to be this crazy of a band. It is showing some insane warming rates. The RRFS shows it a bit better, but again, the band placement is another thing we'll have to watch for because you can see, look at the HRRR versus the RRFS. HRRR is down here, RRFS is up here. But really, the idea is that this band, we just moved to 27 hours. See how it's moved northward. This band will start to set up across south and eastern Pennsylvania and New Jersey. It'll move this way generally, and it will get stronger across the Massachusetts, Connecticut area. That's why there'll be more snowfall over there. But this band is basically our main producer of snowfall this storm is actually going to be really short. If you look at it, it's just going to be an overnight storm, especially for these areas over here. Over here, Sunday is still going to snow, but these areas, it's just going to be an overnight storm pretty much. And a lot of places, rain is going to mix in. So this band is going to be key to seeing how much snow actually falls. Currently, it seems like we have a pretty good handle on it, but we'll have to make sure it actually verifies tomorrow. Because within these bands, there'll be some really heavy snowfall rates, and that'll put down that real snow. And we just look at the snowband probability. This is the WPC's product Weather Prediction Center. The HREF ensemble is an ensemble of high resolution models. So again, this is that snowband I'm talking about right here. This is just some stratiform snow from the entire low pressure system. But this is the band that I'm talking about, the one over here. Watch how it progresses pretty much this way over Massachusetts. So that snowband is going to be the thing that's going to be the main snow producer. All right, so talking about rain and snow, let's move on to where the rain snow line is going to be set up. This is going to be a really important thing for us. It's a lot of people, especially who are living more towards the coast versus more towards the mountains and inland. So let's look at Saturday 7 p.m. for a second. So look at the HRRR. We have our rain snow line set up around a line is pushing HRRR pushing snow even into NYC, which could be a bit of a stretch, but who knows, could happen. So basically mid Somerset County towards the Lehigh Valley, basically south of I-78, it's raining. We see over here it's sleeting, so that's that transition zone because of the sleet. And if we want to see why we are actually getting these that rain snow line, look at this, the banding I was showing over here. That banding is bringing that warm air in, right? As we saw in the frontogenesis, and the temperature advection. This is where the warm air is being brought in by the low pressure. So as we see at the upper levels, 850 millibars, the temperatures are going to start to warm up freezing. This dashed line is the freezing line. So the temperatures are going to warm above freezing, and that's going to cause any snow that's falling. The snow is falling up here at like negative 20 degrees Celsius. But that is going to melt as it gets above 0 degrees Celsius at that 850 millibar layer because of that warming. And we compare some other models. Some models have similar rain snow lines setting up across like basically south of the I-78 corridor at Sunday 7 p.m. However, the NAM 3 kilometer is a bit further south than that. RFS is even further south, and the RDPS is even further south, with that putting snow even in Delaware. But this seems to be a slow outlier in my opinion. We move on to 10 p.m. We can see the HRRR saying HRRR is a pretty fast one with this, saying rain snow line is pushed to basically exclusively northern Jersey. Rain snow line is along the Connecticut coast. That's another key area where a lot of people going to be wondering whether it's going to rain or snow mainly over there. We'll talk about that soon. ARW is also pushed it pretty far north. FV3 is actually keeping it down at the same place it was before I-78 corridor. Same thing with the NSSL. And the NAM 3 kilometer, again, this is just an outlier. This is even further south. And RRFS is pretty much in the middle, I'd say. So where this rain snow line sets up is still something we're not really sure about. We need to be watching this quite closely, especially for people in the coastal south northeast area, Connecticut, Rhode Island, coastal Massachusetts. This is also going to be a really important thing for you guys. So look at this, Sunday 1 a.m. The HRRR shows it's going to be raining pretty much along the coast, raining or sleeting along the coast of Connecticut, especially towards the eastern areas. ARW showing all rain everywhere pretty much in the coastal areas. FV3 is pretty bullish with the snow, keeping the snow everywhere in the coastal south northeast except for the Massachusetts Islands and Cape Cod. Same thing with NSSL. Again, NAM 3 kilometers is a bit of an outlier. RRFS, again, it's pretty much in between. But RRFS is an experimental model. It's a new model that NOAA is testing. I'm just showing this for pretty much just the educational purposes of seeing how this model is going to verify pretty much. Shouldn't really rely too much on this, but I would say that really the scenarios are either pretty much this HRRR depiction, where it's kind of a mix along the coast, this ARW depiction where it's all rain along the coast, or the FV3 prediction where it's snow along the coast. But as we move into the morning hours, definitely it's gonna be raining along the immediate coast. I don't think it's gonna stay snow all the time, especially along the coast, because if we look at the sea surface temperatures, it's around 10 degrees Celsius pretty much everywhere along the coast, if not a little bit less, which 10 degrees Celsius is around 50 degrees Fahrenheit. So the water temperature is around 45 to 50 pretty much all along the northeast coast, well, the south northeast coast and the mid Atlantic. And this means that basically we won't be having any cold air coming off the thing, or relatively cold air. The air coming off the ocean from that 850 millibar low, pulling it this way, is going to be warm. So immediately along the coast, I think it should stay all rain, in my opinion. Well, not all rain. It will start as snow, but then change over to rain later. One more thing that's really key, in my opinion, to the rain snow line is the 850 millibar temperatures. I think this is the number one predictor whether it will snow or rain in your area, the 850 millibar temperature, where that stays. And that is dependent on the low pressure track, as I'll show. So if we look at Sunday at, what time is this? This is 10 p.m. I mean, not Sunday, Saturday. Look at this. All of southern Jersey is above, what's it called? Above 0 degrees Celsius, above freezing. And that is why it is all rain over there. However, pretty much places straight north of this 0 degrees Celsius or 1 degree Celsius line, those are the snow areas. So we look at the HRRR. HRRR is quite a bit farther north with this. NAM 3 kilometers is really like far south with this. That's why it's cold out here. And if we move into, say, Sunday morning hours, the areas around New Jersey, Pennsylvania will be getting colder as the air comes off the backside of the storm, but it's going to be the coastal regions where the focus turns next. Look at Connecticut, the coastal Connecticut area. HRRR is saying all areas are going to be above 233 Celsius temperature. NAM 3 kilometer, again, cold out there, saying even down on Long Island it's going to be cold enough. And yeah, pretty much that's what we're thinking right now for the rain snow line. The rain snow line, it will be dictated by a few things. One is that those winds coming off the coast, like basically how warm they are, which is going to be depending on the low pressure position. Low pressure is over here, winds coming off the ocean. That's all like warm air coming off the ocean. And the 850 millibar temperature, which again is also dependent on the low pressure position. If it's further inland, if it's further north, it's going to be further north, further inland, 0 degrees Celsius lines, isotherms. And basically, if it rises above 2 degrees Celsius, 850 millibar temperature is probably not going to be snowing. Even if the surface is below freezing, that's just going to be sleet, not snow. All right, speaking of snow, let's get to the real stuff here. Let's look at the snow. So first, we are looking at the 10 to 1 snowfall ratio. So basically, this just assumes that the ratio of snow and snow to rain is 10 to 1. So this is not a good forecast for this event. Why? Because the ratios will be way lower than 10 to 1, especially along the coast, and inland they'll be way higher than 10 to 1. Why? Because the snow to rain ratio is dependent on the amount of the moisture there is and the temperature that it is, mainly the temperature. So if the temperatures are more marginal, around 32, 35 degrees Fahrenheit, the ratio is going to be a lot lower. Whereas temperature is 20 degrees Fahrenheit or something, the ratio is going to be way higher than 10 to 1. So basically, I'm just using 10 to 1 as a standardized measurement of how basically heavy the snow will be at times. So we look at things like the HRRR, FV3, it's showing it's going to be heavy even down past the I-78 corridor and along the coastal northeast coast. I just contradicted myself there. I said coastal northeast coast. Well, basically, you guys know what I mean. So basically, south of the I-78 corridor, it's showing basically that's where heavy snow could even get as far low as like Bridgewater, New Jersey, and even approaching like areas in the Lehigh Valley, all covered in heavy snow. But this heavy snow will have different ratios, right? So let's look at the Kuchera ratio real quick. You see how it's all decreased? I'll just go back to the FV3. It's all come back. Before it was showing like 8 or 9 inches over here. Now it's showing 7, especially areas to the south of that where it was showing maybe 6. Now it's showing 2. So the reason for that is Kuchera ratio. It's a mathematical equation that tries to derive the rain to snow ratio from the temperature, things like that. It's not perfect, but it's a much better representation of the rain to snow ratio, and this is generally more accurate. There are some caveats to this, which I'll discuss towards the end. But for now, let's just look at the model forecast. So HRRR is pretty far north. Again, it's a relatively warm and far north model. It's saying the heavy snow in Jersey will be confined to the northern mountainous areas. New York, pretty much everywhere in New York is just going to snow out of this. I'd say Catskills, in my opinion, is probably the bullseye in New York, especially with those lower temperatures, higher snow to rain ratios. Definitely going to be bullseye over there. Berkshires and Massachusetts is another place where it could snow a lot. Even towards Boston, especially the northern Boston suburbs, that could be another place where it could snow even up to a foot potentially, but that could be a bit of a stretch. White Mountains, I would say also that could be another bullseye because the snow to rain ratio is due to the cold temperatures up there. And basically, we see Cape Cod is pretty much no snow. Coastal Northeast is very dicey, especially Connecticut towards the southwestern area. And Long Island, I would say, honestly, it could be snowing, but pretty much almost none will accumulate, in my opinion. That's what I'm thinking right now. And the rain snow line in New Jersey, I would say probably the I-78. I-78 is pretty much the line. And I would say significant snow accumulations are only going to occur about 500 feet. This elevation could be a decent factor around these rain snow lines. I would say if you're pretty close to it, especially if you're on the north side of it, if you're greater than 500 feet in the air, you're going to be colder. You have a higher chance of significant, well, not really significant, just like measurable snowfall accumulations that don't melt by the time you wake up. Same thing, Pennsylvania I-78 corridor is a pretty great measure of where the rain snow line will be. But pretty much it will snow across a lot of these areas, except for probably the immediate coastal areas. Just that where does it accumulate, where does it stay heavy for long enough, and that's what I'm calling the rain snow line for this event. New Jersey, again, just to recap, I'd say I-78. Coastal Northeast is really dicey, honestly, in my opinion. I'd say just listen to the National Weather Service for this because I haven't looked too much into this. But I would say pretty much the coast area is probably not going to receive that much of measurable snow. You definitely have to go inland, and then it's dependent on the low pressure track. Does it track over the Cape or does it track out to sea, as per the areas like over here, Rhode Island especially. So some other models, ARW is an even warmer model than the HRRR it seems, but it has some much more significant snowfall totals over the interior, probably because it's further north. FV3 is a bit further south, and you see these significant snowfall totals across all of Massachusetts in this one, same thing all of Connecticut. NSSL is kind of similar to that. Man 3 kilometers, significant cold out year in my opinion, has heavy snow even approaching the northern suburbs of Philadelphia. Even in Philadelphia, it's saying like 2 inches of snow. I don't think it's probably not gonna happen in my opinion. So this is the main culprit, I would say. Look at the sounding. This is a sounding representation of temperature in the atmosphere. The 850 millibar temperature, I've said this so many times already. When it is above freezing, it's probably not going to snow because that snow is going to melt, especially when it's more than 2 degrees above freezing. If it does come back like this to around freezing at the surface, that could be sleet. But if it doesn't, it's just going to stay rain because that snow is just melting. So let's just look at the WPC expectations as per snowfall. We can see over here, WPC is saying pretty much just north of Somerset County in New Jersey is where the 6-inch plus snowfalls totals are going to happen. And it's saying the bullseye is going to be west of Boston, southeastern New Hampshire, extreme southwestern Maine, 1 foot plus snow totals. This is the legend over here. Just pick out your region, see what you think you're going to get. This is the WPC. Move on to the national blend of models, which is pretty much just a blend of a lot of different models that is like calibrated. The WPC was actual like people forecasting that. This is a bunch of models combined together. Again, this is the thing. This is the legend. Pick out your place. Figure out what you're going to get. Again, this is saying the bullseye is going to be the Massachusetts area, but this one has a much smaller 12-foot. 1 foot bullseye. 12 feet would be quite a bit. But 1 foot is what I'm talking about, not 12 feet. In my personal opinion, I think one of the highest snowfall total regions are going to be the Catskills because of those cold temperatures. But if the storm does move far north enough, the White Mountains could top out that, especially Mount Washington. We look at just the official NWS forecast of the snowfall, and we can see that actually this is QPF first. We can just see pretty much across New Jersey, general 1 to 1.2 inches. Same thing across the Massachusetts area as that heavier precipitation comes around. Everywhere else, pretty much 0.8 inches. Basically, it's really pretty much 0.8 to 1.2 inches of QPF in the significantly impacted regions here. And we want to look at the snow. We can see again they're pretty much making out the I-78 corridor as the line in New Jersey. We can see Catskills getting significant snowfall. We can see a sharp gradient along the coast in Connecticut, Rhode Island, and Massachusetts. Massachusetts, they push the gradient a bit inland because the low could track like that, something like that, and go off. Boston is looking pretty close as to whether you get more like 3 inches of snow or 4 inches of snow or like 10 inches of snow. Again, we'll have to watch the low pressure track. But definitely areas north and west of Boston, solid amount of snow, 10 to 12 inches, I would say, definitely. Let's look at just a few caveats over here. Let's just look at the soil temperatures currently in New Jersey. Soil temperatures, I went out today at around 3 o'clock, and I saw the ground around my house. I live around here, northern Somerset County. The ground was frozen. So I don't think soil temperatures are going to be too much of a player in the accumulations, but really the initial accumulation, how much the snow can stick to the ground in your area, regardless where you are, even if you're not in New Jersey, regardless where you are, if you are near the rain snow line, the amount of snow that is sticking to the ground towards the beginning of the event is going to be pretty important, because if it's sticking just from the start, then your snowfall totals are probably going to be towards the higher end of what they could be for your area. Not like really high, but what they could be. So it'll be like a good case. And if it's not sticking at all in the beginning, if it's really, really slushy, just melting, then it's probably a bad sign, not going to be as much of accumulation. Some other caveats there could be with these snowfall accumulation potential is the low pressure track. As I've said so many times, it's going to dictate the 850 millibar temps, which again then dictate the rain snow line. So if the low pressure drops further south, this rain snow line will come south with it. And if the low pressure moves north, that rain snow line will move with it north. And if it is inland, the rain snow line will be pushed further inland. If it is more coastal, it'll be, if it is more out to sea, the rain snow line will be pulled towards the coast. So that's pretty much the summary as per the low pressure. Finally, just mixing issues. When you get sleet or rain mixing in with the snow, that basically takes away QPF from the snow that could be put to getting snow on the ground. And along with that, rain and sleet tend to compact snow. So it could make your accumulation seem lower if it ends up sleeting or raining in your area for a significant amount of time. So that's another thing that you're going to have to watch for with your accumulations. But honestly, I'd say this forecast, the NWS forecast, that's the best forecast you could use, in my opinion, because they are coming from the experts at the NWS. So definitely pay attention tomorrow in case there are any changes. But I think pretty much we are at the point where we have enough confidence to call this the forecast. Really just some minor tracks with the low that could affect people at the rain snow line. But besides that, I'd say we are pretty much done with this event, forecasting it. The event will start across New Jersey tomorrow after midday. And I will definitely be making some update videos in the snowstorm for you guys. And I'll be telling you what's happening over here. Is it verifying? Is it not? And yeah, I'll just be enjoying the snow. I hope you guys enjoy the snow too. Thanks for watching, and I hope you learned something new, and have a great day.